go to fundamental problem 13.1, right? So the problem says you have a 1.25 meter long rod made from a 25mm diameter steel rod, from a 25mm diameter steel rod, and the question asks you to determine the critical buckling load if the ends are fixed supported. Alright, so basically it's something like this. I mean, there is no diagram, but one end is fixed, right? This is the rod, okay? And then at the other end is fixed as well. You see, fixed and fixed. And then the question tells you that the length, total length is 1.25 meter, okay? And the length, right? And the diameter is how much? 25mm, okay? So this is diameter, okay? 25mm diameter. And question asks you to find the critical buckling load, which is P critical. Alright? The ends are fixed, both ends. So the question asks you to use E equals to 200 gigapascal, which is obviously a steel, okay? And you are given the yield strength of steel to be 250 megapascal. Right? So the question asks you to find what is the critical buckling load, P critical. So what is the formula for this? Okay, the formula is, what is the critical load formula? P critical equals to pi squared I over KL square. Okay, remember this. Both K and L are square, not KL square. This is wrong, super wrong. Don't do that. Alright? Okay. So basically you have your E, right? For steel is 200 gigapascal. You have your length, which is 1.25 meter. What is your K? What is your I? Okay? Straightforward, as simple as that. So basically you apply the P, okay, and of course there is a reaction P at the bottom as well, okay, and then you want to see how much the load, which will be the critical load, once this column starts to buckle, deflected sideways. Alright, deflected sideways. Okay, okay. So how to do this? You need to find what is your I. Okay, so here your K is 0.5, half. Why? Because the condition, the condition of this, the support, okay, at one end it is fixed, and at the end it is fixed and fixed, which means fixed ends. So the K is 0.05, right? And how about your I? In this case, your I in XX or YY direction will be the same, right? XX or YY is the same, which means that basically this is the cross section, right? So if you say that this is XX or this is YY, they are the same, which is actually, in this case, we have done this so many times already. Pi over 4, C power of 4. So pi over 4 times C is the radius, not diameter, radius, okay? So it is 25 over 2 power 4. Right, so your I is, if you hit your calculator, then you will have your I to be 19174.76 millimeter to power 4. Right? Okay, now we put everything to the equation. So your P critical load is pi squared, okay? E is the E for steel, which is 200 gigapascal, right? And the I is this I, 19174.76, okay? And then denominator, which K is 0.5 times L is 1.25 meter. Here I change to millimeter, okay? 1250, 1250, and let's make it this way, is square, right? Remember, K times L square, right? So your critical, your P critical buckling load is 96.89 kilometer. Alright? So what you have to do, though actually the question asks you to find what is the critical buckling load, then this is the answer, okay? But actually you need to check. You need to check whether this critical buckling load will be reached first, or the yield strength the yield strength will be surpassed first. Okay? So what you have to do is you have to check for the critical buckling stress, which is P critical over the cross-section area, right? So 96.89 over pi r squared, which is 12.5 squared, isn't it? The cross-section area of the circle. So you will get your answer. Sorry, 96.89. Yeah, and then you will get your answer to be in gigapascal by the way, but you change it to megapascal, it will be 197.4 megapascal. Okay, so can you see that this critical buckling stress is actually, compared to this, the strength of the material itself. So you can see that sigma critical, which is this 197, is actually less than yield strength of the material itself, which is 250 megapascal. So what does it mean by that is this rod, okay, the rod will buckle first. Alright, why this is important to be checked? The reason is because there are two in this column. You apply this axial load on the column. There are two possible failure modes, right? One is when the yield strength is reached, right? The one that you have learned throughout the MOM, this course, alright? But another one is the one which we learn in this chapter, which is the buckling load. The material doesn't fail, but the structure fails, alright? It starts to buckle sideways. Actually, we don't want that to happen. So we have to check which one of these comes first. In this case, actually this critical buckling load will come first, because the critical buckling stress, okay, this one is smaller than sigma y. So this one will happen before the failure of the material, right?